Okay. We'll try to see if we can get this. Well, we will try to be
That's a good
very
argument.
punctual.
That's a good argument, yes. Okay.
We have another 2 minutes, but we will start exactly on time so that we do not delay the next session.
I hope so. I am the latest speaker. As you know, I am replacing Surah Ajit, who is not available now. So I am Paulus, and I am. And the official card, which I have here, is still the name of Surah, but no, it's already mixed, fixed. Fixed.
Okay.
Yes. Yeah.
Good.
So I am an invested interest to start also punctually.
Yes, and I hope you will all forgive me then. As a session chair, I will cut off the discussions then after 15 minutes so that the next presenter can start punctually, because we would not want the fourth presenter to suffer and only have 5 minutes. That would be unfair.
Something like that, yeah, that would be very pleasant for me. And other people too, yes.
Yes.
But of course, there is the chat channel also.
Yes.
For people who want to say something more.
Okay, it's 2 o'clock. I'd like to welcome you all then to our session, Feedback, Assessment, and Grading Mechanisms. We have 4 papers today that we will be discussing. I hope that you have all watched the videos and read the papers ahead of time. I'd like to ask each presenter to show your teaser slide and give us a short 2 to 3 minute summary of your paper. Next, we'll have each discussant then also start off the discussion for us. And then please, when you have questions, use the blue hand raiser. If you look at participants, then you can see how to raise your hand, and I will be calling you in the order that you raise your hands. Okay, our first presenter today is Jose Bernardo Roja. Are you here today, Jose? Yes.
Yeah, I'm here.
Okay, you may have the floor. Could you share your video, your slide with us?
Yeah, give me a second. Share. Are you seeing it?
Okay.
Yes, we see your slide. Excellent.
Okay. So our work is a systematic review on quizzes and its use in software engineering education, and particularly as a tool for self-regulated learning. We are trying to answer a group of research questions, namely, if quizzes are used in software engineering education, spoiler alert, they are. How are they used in software engineering education? We mainly found 3 different important groups of answers for this question, namely, what type of application are they used? What type of application of quizzes are they used in? The context of the application, if it's inside a lecture or outside a lecture, and the type of course or learning system where they were applied on. Our third question is, if quizzes are quizzes used in software engineering education for the self-regulation of learning? What we found is that they are indeed used for the self-regulation of learning, but and we found several examples that approached and focused on each of the different phases of the Zimmerman cyclical models and all types of self-regulated learning activities. But most research that we found and looked at did not examine this explicitly. They took no particular care. Our fourth question is, how are they used? Again, it's a bit of the same question. They are used in the self-regulation of learning, but they are not used explicitly. So the authors tend not to pay particular attention to the theory that can support the self-regulation of learning. And our final question was, how can we improve the use of quizzes in software engineering education? We did not find clear answers for this, though we did leave some suggestions, namely trying to minimize negative aspects that were identified and trying to maximize positive aspects, and approaching the theoretical base explicitly so that you can take particular care to integrate some of the activities that are proposed, or emphasize and take better advantage of the benefits that are proposed in the theoretical base. This is basically it as a presentation teaser.
Okay, thank you very much. Our first discussant is Ben Clegg.
Hi.
Hi.
I like the paper. I thought it was a really good survey paper. And I also thought that the quiz repository thing was quite a very clearly useful tool for tutors. So good job, first of all. So I guess to start the questions, I guess my first question would be, the clearest question to me is what types of quizzes do you personally use when teaching?
Well, currently I'm not teaching because I'm only a PhD student.
I see.
But we are using, in the context of our quiz tutor, we are using online quizzes, mostly online quizzes. Those are the main types that we are running, and this work was made in the context of an international project, an European project. And yesterday there was a tutorial session on this project, and this tool was also the quiz tool was also presented, and it ended up becoming quite important because this work started about 2 years ago, and due to the pandemic, it ended up even being used for evaluation and for test taking due to the limitations of the pandemic. But they are mostly online quizzes with multiple answers.
That makes sense. Yeah, I think that's, from my experience, that seems to be quite common. At least we use that in our institution the most, I believe. Yeah. And another question, I suppose, is you identified a couple of challenges in the paper, particularly on the quizzes can introduce student anxiety, and the preparation quizzes didn't have as much of an impact. Do you have any ideas of how to kind of tackle these challenges at all?
Well, if I recall correctly, let me go back to the actual slides, the big presentation, just to make sure I'm not speaking out of turn. The anxiety was mostly introduced due to pop quizzes. So pop quizzes need to be made carefully so that students aren't dreading going into class. So that probably requires some pedagogical study of why that effect happens. But the other part of the question was, sorry?
I believe the preparation quizzes, yeah.
Preparation quizzes. Let me see where that is. Preparation quizzes. Here, repeat the question, please. I'm sorry.
So I believe in the paper you mentioned that preparation quizzes don't have as much impact on
that was one of the conclusions of one of the studies that we saw. That may have been an outlier. That's why more work is required. It might have been due to they existed, but they were not adhered to. There wasn't enough engagement for students to use them. But it comes down to that. Those were effects that were detected. A lot of them were reported partially as one-off. So some of the conclusions related to the positive and negative aspects aren't as strong as they could be, because quite often the papers that we looked at didn't report them consistently, nor in the same manner. So having a clear picture regarding that aspect was tricky. So we basically so we had these positive aspects, these negative aspects. Concerning the preparation, it seems natural, but this is speculation, that it probably comes down to engagement engagement with adherence.
I can imagine students probably wouldn't go out of their way to make preparation quizzes unless if they were forced to a lot of the time. I have a couple more questions as well, but I'd like to ask anyone else if they have any first.
Okay, I see a hand raised. Ben Reed. Ben, would you like to ask a question?
Hi, yeah. So I appreciate this paper. One of the things I noticed with the pandemic is that a lot of professors started quizzing more. Like we started using quizzes more, hopefully because engagement during the pandemic has been horrible, right? I was very excited about it too. I felt like it would inspire learning and, you know, give students feedback. But I have seen, and this is completely anecdotal, I was wondering if you saw this as well. Students oftentimes they perceive it as busy work versus learning, right? It's just extra work that we're giving just to like take up time rather than actually measure anything, or, you know, it's just too much, right? I guess it's slightly related to anxiety, but I was wondering if you noticed any, I guess, increase or decrease in value perceived by students of quizzes.
I can, like I said, I can't really answer that question because I'm not teaching. I'm only a PhD student. But from my experience in some classes or online courses that I have taken, for example, I took the machine learning specialization that Andrew Ngu at Stanford and then at deeplearning.ai did. One thing that I noticed was that, in a sense, at least the in-lecture classes, because he has his videos and he has some quizzes in lecture, they help me understand stuff and go back and review stuff that I thought I had understood and didn't. Mm-hmm. So my personal view is that it can be useful, if not done to an excess where you feel like it's busy work. But this is my personal view. I cannot speak to how students are feeling currently concerning that. Most of the reports stories that I have heard from colleagues that are actually doing at least some assistant work is related to people wanting to stop going to classes, because here in Portugal we have a semi-mixed system where practical classes are having attendance requirement every 2 weeks or something like that. Mm-hmm. So that has been most of the experience. But quizzes, at least in the lectures, my personal opinion is that they can help promote engagement. If it's quizzes outside lectures, sometimes, yeah, students can find that busy work. Inside the lectures, it can promote engagement and forcing students to review and actually understand something before advancing towards the next idea that sometimes builds on that idea that they misunderstood.
Thank you.
You're welcome.
Okay, thanks a lot. Any more questions? We have time for maybe one more question.
Yes, I have one.
Yes, Paul.
I didn't find the mysterious button you were referring to. Where I can
okay.
But I have now my turn. Okay, formerly you said, Jose, that indeed quizzes are multiple choice tests, something like that, formally. Yeah. My question is, what is in practical use of it? What is the difference between it?
Between
quizzes
and multiple choices. Some type of quizzes can be multiple choices, others are not. Just to be clear, they tend to be from what I saw, but not all of them are multiple choice. I'm not sure. I need to look at the paper. I'm not sure that I defined them in the paper as multiple choices. I'm not sure.
So what would be the difference? What would be the difference then?
The difference between quizzes and the long form exam, for example?
Yes.
Well, I think that in the literature, especially the literature that relates to the activities, they are explicit in saying quizzes or exams. So the effects will be similar because they are grouped, at least at the tutorial level, at a similar way. And the activities that they support are the same. So they all support revision sheets. Let me look at this. Let me try and share this.
Okay.
Presentation. It's a bit better. Can you see it?
Not yet.
Okay, I haven't pressed the button. Okay.
Yes,
So
now it is.
if you look at this, which is an application of the Zimmerman cyclical models, trying to extrapolate activity, self-reflection activities that you can do. This is both for quizzes and exams. And you can see that exams allow the possibility of knowledge surveys when you're doing the performance phase. So when you're doing an exam, and after an exam, they also support the same thing. Self-reflection of the students and diagnosis of the preparation problems.
Okay.
And before, you need to develop test questions in the same manner as you would for a quiz or for an exam. And you would create a review sheet and do pre-exam knowledge surveys. So in this sense, we tend to use, from what I noticed, we tend to use quizzes for something that is a bit shorter for exam, but at least from a theoretical standpoint, and particularly in the case of self-regulation, you would have the opportunities for the same type of self-regulation of learning.
Okay.
Does that answer your question?
Yes. Thank you very much.
Okay, thank you very much. Perfect landing, 2:15. Our second paper will be presented by Ben Clegg, The Influence of Test Suite Properties on Automated Grading.
Hi. Okay, I'll get started then. Hi everyone, I'm Ben Clegg. I'm a PhD student at the University of Sheffield. And I'm going to quickly summarize my work on the tile that you kindly just saved of this effort of reading. Yes, so the motivation of this work is that test suites can vary greatly, especially those that are used in grading, such as in test adequacy, variability to detect faults, and in size. This means that grades that are generated by these suites can be inconsistent, which means that students can receive grades that are either too low or too high, which produces some form of unfairness. It also introduces some problems, particularly if a test suite isn't adequate, that some mistakes aren't detected, which can prevent automatic feedback from being generated. And this all can lead to a detriment in teaching. We conducted an empirical study with two research questions in mind. First, how much the grades vary with different suites, and second, what properties impact grade the most. We've also provided 3 suggestions to tutors. We performed an experiment by randomly sampling test suites from a set of tests, and we used artificial faults called mutants, which Gordon explained in his talk yesterday, if you haven't seen that. In short, they are modifications to a correct program that introduce faults. For our first research question, for every fault in every test suite, we calculated a grade based on the percentage of tests that pass. And for research question 2, we observed the properties of different test suites and performed a linear regression analysis. For first research question, I admit these charts might be a bit blurry here, but they're more clear in the video and in the paper. We found a mean grade for all single faults across all test suites of sizes from 10 tests to 100 tests were 96.5%, which means about 3.5% is lost. But there's also a standard deviation of about 3%. So this standard deviation accounts for about 84% of the lost grades. So either these faults can either have almost no grades lost or can have almost double the grades lost. And these grades vary across different suites and different sizes. Oh my goodness, I've realized that I have not got the slides open. This is a small mistake. Thank you for pointing that out to me, Gordon. I forgot to press the button. Fortunately, the rest of it didn't have any visual material, so it's not so bad. Okay. So for research question 2 results, we use the beta coefficients of the linear regression as a relative importance measure. And we found that coverage has the greatest impact. So suites that cover more of the code have more of an impact, tend to have higher grades, I believe. Recovering lines also has an impact, and the mutation score, which is essentially a measure of how many other faults the test suite detects, also does have an impact too, a negative impact. We've used these results to produce 3 suggestions to tutors. Firstly, that they should aim to produce 100% coverage in their test suites. Secondly, to avoid unnecessarily recovering their code. And thirdly, to check their test suites that detect real faults or artificial faults. Yeah, that's my summary. So I'm open to any questions. I'll stop sharing the screen now.
Okay, thanks, Ben. The discussants are Jason Yoder and Steve Chenoweth. Jason and Steve, do one of you want to start first?
Let's start off, Steve.
Yeah, okay. So I was really curious if you'd had a chance since writing the paper to try some of these ideas out in real classes and see, if the improved reducing the bias of the tests and things actually worked out on the way students actually write their code.
So I'm like the previous presenter, I'm unfortunately just a PhD student, so I don't get to make as much decisions on grading myself. And during the time, I think the last time I helped with making a test suite for grading was whilst I was writing this paper, so unfortunately I didn't really get the chance to implement it. However, I am writing a grading tool, and I'm quite interested in implementing mutation analysis inside that tool to help with a third suggestion. And I will admit, with the whilst making those grading test suites for the last assignment I helped to develop, we did achieve about 100% coverage on most of the classes, and we did try to keep each method quite separated where possible. So we had a mark scheme criteria. The students had to answer questions based on data that we read in. So we had each of those as a single method and non-design, so we didn't have to recover parts of the code that would cause problems. So I guess to answer your question, in some ways, yes, but in the more complex ways with mutation analysis, not quite. That's planned for the future.
Yeah, I really appreciated your emphasis on redundant test coverage, by the way. Having written tests like this for, not for automated grading, but for my graders to go through and do the grading, it's pretty easy to write things that actually test the same thing. I mean, essentially they look different as test cases, but they're testing the same things about the code. And then grading on the basis of that would definitely bias the way it was graded.
Yeah.
Can you see a way of avoiding that? I mean, strategically, as you're looking at your test cases and looking at the code?
I think that, so I did start doing some work on trying to automatically generate weights to try and avoid this problem, although it turned out to be a very difficult problem space, which I couldn't quite find a solution for. As far as strategies that you can actually employ, I first of all want to say I think that sometimes recovering can be good and it can be fine, as long as, like you say, they're covering different cases, or if, say, one particular element is particularly important to test. Though I think if you want to try avoiding it, like if you should have things separated, the problem is kind of easiest tackled earlier on, and that's when you're kind of defining the assignment itself. To say, if you're providing students with a Scalison class, to trying to keep the methods quite separated, because if you don't do that, it becomes kind of impossible to separate test cases, just naturally of how the program runs. So I think my advice to anyone would be to try to do it in the architecture stage almost, although I admit it's quite difficult.
Yeah, it's a new skill for us as we're
it's
teaching.
very challenging.
Yeah. Okay, well, I think I'd like my colleague Jason to have a chance to ask a question also.
Sure.
Yeah, sure. So, yeah, I think it's really cool trying to, yeah, do this mutation to imitate the kind of mistakes that students make. And I would like to know, one of the things that's also interesting to me is we're finding that sometimes students end up becoming very reliant on unit tests, kind of in the intro courses, and then later on, it seems like they struggle if they're not, just given tons and tons of help from these unit tests, so that they can kind of get incremental, clues kind of along the way, but it can become, I think, problematic in some cases for students. I didn't know if you had any experience with that or thoughts about ways that we can create unit tests that are fair, but also maybe don't help too much, or a way to kind of maybe provide less in an incremental fashion as they go to higher level courses.
Yeah, it's a interesting problem. In our I mostly have experience with our Java module. And in that Java module, we typically haven't historically provided students with unit tests. The unit tests were used in a private sense when we compute grades. I have encouraged them to start using some unit tests to kind of make sure that students can, like you say, have some feedback whilst they're making an assignment. Although I think I think perhaps one way would be to encourage students to write their own tests, to teach them, like, yeah, this is how you write a unit test, and this is what a good test is, which admittedly could be an entire module in and of itself. It's a entire field of software engineering. So I think that's probably, in my opinion, the most effective way, because I think that teaching students to kind of to see the importance in unit tests is very important. Like, that's absolutely important, and it's something that every module should try to do at least a bit. However, I suppose there is a risk, like you say, if students maybe assuming all unit tests are like gifts from God, right? That they're perfect and that they're always going to reveal faults, because that's not necessarily the case. So I think that maybe, getting them to write their own tests could be of some benefit there, maybe.
Well, thanks. Great.
Okay, thanks. We have time for one more short question. Marian Down has his hand raised.
Yes, very nice paper. I was wondering if you could say a little bit about the students' attitude towards this approach. I mean, do they accept being graded by a machine?
It's quite an interesting one, because I think, again, with the module I have the most experience in, we tell students that they will be graded automatically. We do say there will be some human oversight. There are some students I've been told have rejected some of the things, saying, "Oh, these grades are just they're wrong," even though we couldn't run their code at all, for example. So you do get cases like that from my experience. I think it's an interesting challenge. I think that if students often compare their solutions to each other, I find, after the fact. So if they're clearly getting very different grades for relatively similar solutions, then they probably will be a bit disheartened by that. But if they do see that maybe the solutions are different, that like the tests are an objective measure somehow, then I think they might, in a way, kind of be more relaxed about it. I think it's very important to be very clear with the students that the unit tests are being used in this way, or whatever automated approach you're using, like static analysis. Because if the student assumes that it will be manually graded and it's automatically graded, they might take some issue with that. But if you are upfront with them and say, look, we have to automatically grade it to be able to grade anyone's solution, I think then they might be a bit more reasonable about it. So yeah, does that answer your question?
Yes, thank you very much.
Thank you. Is there something in the chat? Oh, right. That might have been. Yeah, is there any other questions, I suppose? Or do we not have the time?
Patricia, you're
Christopher's raised his hand. I think we have time for a short question.
Yeah, it was just a short question. Were the students given the test prototypes or test documentations beforehand, or were the unit tests quite hidden from them?
So the unit tests themselves were mostly hidden, with some exceptions. We did provide them with some tests that were like, yeah, this is just to check that their code runs and to do some very baseline testing in a much less detail. They were given a full specification though and told like what to do and what not to do. Like we had, say, some classes that they were told not to modify. And you still had some students to try to modify them, but for the most part, they did follow the specification. I think, again, it is a trade-off because over-specification does kind of limit creativity sometimes. So I think there is a happy middle ground somewhere. And there are other tools available which do provide some form of, do kind of enable that somehow by allowing classes to be modified at runtime, that sort of thing. So perhaps those can be used as well. Yeah.
Okay, thanks, Ben.
Yeah, no problem. Thank you.
Our next presenters are Jason Yoder and Steve Chenoweth. Their paper is titled Reflection for Recovery, Exam Wrappers in an Object-Oriented Software Development Course to Help Struggling Students Improve Future Exam Scores.
All right. Everybody see that all right?
Yes.
Okay. Cool. Yeah, so thanks for coming and yeah, hearing more about, and look forward to some questions. So basically, there's a second level programming course that we've been teaching here at Rose for a number of years, and a lot of times because we're on a quarter system, we have 10 weeks. By the time they take the first exam in Java, a lot of students really struggle, and one of the things that we had been trying to do is offer a makeup exam, right? So we don't have students that need to fail and retake the course. Hopefully they can have a chance to come back, but that's a lot of work. One of the things that we decided to offer as an alternative was a exam wrapper where students go and basically see what kind of mistakes they made on the exam, reflect a little bit about how they prepared for the exam, where they lost points, and make an action plan for how they can do better on future exams. And so we ended up looking at data from students where these exam wrappers were present and where they were not. And so there's a historical study kind of looking at how the student population, the students that did well, the ones that did worse, how did they do relative to their academic peers over the quarter. And we ended up having around 1,000 students worth of data, which was really nice to be able to measure effect sizes. And the overall takeaway was that the students that were struggling, the ones that were doing kind of in the lower quartile in general, tended to have a better improvement relative to their academic peers when we had these exam wrappers present. And so it was something that was possible in large part because we had so many students. Other work in this area has not often had a strong measure of how much improvement occurs, but in this case, we had enough students that did poorly that we could see what appeared to be a significant effect. So there's a number of different benefits. Students mentioned reporting in a kind of assessment of how effective was this wrapper for you, such as being able to improve their understanding of concepts as they were reflecting, realizing that they were managing their time poorly and had different ways to improve that moving forward. And also just kind of verifying that things that they did learn, they learned properly as they went and reworked problems. Yeah, I think that's a good short summary. Steve, anything else you want to add?
No, that's the basics. I'd love to hear what questions our colleagues have.
Okay, thank you very much. I think to start off the discussion, Paul Hubert Vossen
Yes.
is assigned as a discussant.
Okay. Thank you very much. Also for this short introduction. What I did is the following. I have two questions, two concrete questions, but before I pose them, I would like to give a short review so that you know what I understood from your study. So it is the following. This paper is about axiom wrappers, as you explained, an approach to get more out of axioms than just grades plus general remarks about what went wrong during them. In the introduction, it is defined as a guided personal analysis of performance achieved at a non-axiom. The idea of axiom wrapper is not new, however, and it may take on quite different forms. Most likely, I think axiom wrappers grew out of an age-old practice of giving students a chance to talk with the instructor about the axiom results. In particular, when students can't explain for themselves why they performed so badly on a test. Hence the phrase struggling students. However, axiom wrappers are much more than talking with the professor or someone, as they aim at skills which go under the names of learning strategy, metacognition, etc. Skills which are not evenly distributed across different students. Now, as you already explained to us, the paper focuses entirely on the question whether axiom wrappers can indeed assist in helping those struggling students to achieve better results. That implies, in my view, that axiom wrappers are instances of approaches to what's usually called formative assessment. That is, assessment when learning is still taking place, assessment for learning. To this end, you already explained you used and analyzed historical data over the last 5 years for courses which at least one occasion of axiom wrappers, and a clean-up sample of almost 1,000 students. I want to emphasize that the nature and size of this study is pretty unusual for educational research on a formative assessment instrument, and I congratulate you with doing this research. And the authors did a great job in, I believe, taking care of potential confounding factors, which is very useful in when using historical data. Their main conclusion, statistically significant, is that axiom wrappers appear to work, at least for the target population, struggling students who use the axiom wrapper on axiom 1 and 2 and to perform better on the comprehensive final axiom. To conclude, I agree with the statement of the authors that measuring the impact of some learning tool is non-trivial, and that further study of axiom wrappers especially is required under more controlled conditions to find out what exactly makes axiom wrappers so effective, even beyond ongoing improvements in teaching, training, and remedial actions of another type. Okay, do you want to comment on this short review already, or shall I proceed with my two questions?
I think that I liked what you said. I think you, definitely got the takeaways and some of the intricacies and challenges. So yeah, I'd be happy to hear the question. Yeah.
Okay, let's go on that then. First, I struggled a bit with the concept of axiom wrapper. I'm not sure if I understood its meaning from the definition you gave. On top of that, you introduced the concept of redemptive axiom wrapper and assessment wrapper. So I'm a little bit lost. Especially because I didn't find any explicit definitions of the terms. Could you please explain those concepts a little bit? What goes on for the student concretely when he does an axiom wrapper?
Okay, so you're asking about, I'm not sure I got all of everything that you said there, but you want to know like the specifics of what we actually did with the wrapper? Is that what you're asking?
Not what you did with the wrapper, what the wrapper is for the student.
Okay.
How does he proceed?
Okay, yeah, so I thought that might be a question that would come up. So Basically, what we had was we made something where they would basically indicate how they prepared for an exam. So basically a number of different steps here. So indicate, how did they practice? Did they practice at all? Did they have particular approaches that they were using? And we have a list of ways that they may have prepared that have been indicate to not be as effective or problematic. So not eating enough, not sleeping enough. And then we also listed a second set of preparations that have been shown to be more effective. So distributed practice instead of mass practice, reorganizing notes, that type of thing. Other strategies such as timing themselves and not getting help as they're doing like a practice exam, for instance. So right off the bat, kind of giving them an idea of like how they prepared and maybe some other things that they could do better. We have them basically list anything else extraneous that may have affected things. And then we actually have them identify what are all the different places you lost points on the exam. Is there a pattern to that data? Did you perhaps read too quickly through the exam and maybe you didn't sleep enough and so you were rushed through, or maybe they're just trying to go through too quickly. So identifying patterns, where are they losing points? And then after that, basically come up with an action plan. How can you prepare for the next exam based on what you've identified here? And so, basically that's what they end up doing. They also go and they rework the problems that they missed and submit those. The rubric's already made, so we can have graders, regrade things they're already familiar with. So it doesn't take a ton of work. I generally tried to give them some feedback. I look at their action plan and say like, that looks good. Or you're like, oh, seems like you're missing something really glaringly obvious. You can point it out, but you don't seem to have a plan to adapt to it.
Yeah, fine. Okay, that is, makes it a little bit more clear to me. And yes, it was more or less what I thought you. So you do actively help them in setting up a new work plan, action plan, as you call it.
Yes.
Right. You said, so they come up with the action plan and then I'll usually give a little bit of feedback.
Yeah. Okay. Now I come to my worry, and that's the following. You wrote two things, that action wrappers are used to help struggling students to achieve better results on the next exam, especially the final one, of course. And secondly, that students completing an action wrapper will be rewarded a small percentage, 10 to 30% of additional action points for doing action corrections. Now my worry is the following. Could it be the case that the total action results, that is action 1 plus 2 plus a comprehensive final action, will be heavily flawed, especially for those struggling students, because the effects of doing an action record will be counted twice or more for them. Once in the exam, and then again in the next exam, which they were now better prepared and motivated for. And is this following conclusion warranted? The gap between top and bottom achievers will be closed somewhat by these action wrappers, but only for the bottom side. That is, for the middle and the top achievers, action wrappers may have no significant effects.
Gotcha. Yeah, so that's a great question, and part of the challenge that we were faced with, if we had the exact same exam every year, and we were doing it across terms, there's a lot of things that we could do. So with a more controlled setup, there's a lot of things that we could measure that we couldn't in this case, because we're trying to assess, like, is there a significant for any population? We can only do that kind of relative to the specific. Maybe we can try to make an exam very fair, but there's all kinds of constraints that can influence things. So in terms of what we were able to measure, we could measure this change in relative performance from the struggling students. But just because that's the only thing we could really measure here, that doesn't mean that there can't be other benefits for students doing the exam wrappers, even ones that are doing very well. For instance, we mentioned several of the different things that students reported themselves in terms of what was beneficial about the exam wrapper to them. We asked them, what did you like about it? What did you dislike about it? And there were these kind of general takeaways that, had mentioned here in my teaser, kind of the grasping concept, time management. And I think I had in my presentation even a slide that talking about specific examples. So even a student that's doing super well, but they're motivated and they want to improve, they may be in a situation where they realize a pattern, something that they did wrong, or maybe they weren't even aware of some of these studying strategies, such as reorganizing notes. And so if they are able to see that and make a correction, we might not be able to measure that effect, but there is literature suggesting a variety of effects from exam wrappers beyond just kind of this recovery catch-up mechanism.
Okay, thank you very much. Yes, this helps. Okay, I have some 3 comments, but I will spare them and send them to you by email or something like that.
Great.
About the content, 3 things to
Slack.
improve your paper.
Post them in the Slack so we can all join the discussion.
In the Slacks. Okay, right. Thank you.
Yeah, I think that's a great idea, Bastian. If you post things to Slack, then they last a lot longer than just in the chat, and we can all take part in the discussion. Thank you very much for this discussion and for your paper, Stephen and Jason. Our 4th paper for this session is Paul Hubert, Towards a Paradigm Change in Group and Peer Assessment in Software Engineering Education. Would you like to show us your teaser slide, Paul?
Yes, I will do that. Let's see what is the Bildschirm trial. Okay. There it is, like this. I hope it is the one, the correct one. Can you see it?
Yes, yes.
Okay.
Now we can see it.
Okay. It is a paradigm change we are provoking. With scores for testing and assessing, instructors usually means numbers on some bounded scale. For instance, the Likert scale from 1 to n5, for instance. We will focus here on the standard scale of percentages. Percentages between 0 and 1, they are mostly presented, as you know, with an integer number and the percentage sign. So far, so good. Common sense and fairness principles imply that the conventional rules of arithmetic cannot be applied. I will give you some examples. Here they are. For instance, if you take the inverse of 70%, minus 70%, then you fall outside the range of standard percentages, from 0 to 100. The second example, 70% plus 20% is 90%, but it's strange. 20% means failing, so you would expect some less than 70%. The other 2 examples that follow, 70% and 40%, and 2 times 70%, again result in a percentage which is not in the range you have defined before. And the 5th is very particular, because 70% is a passing score. If you divide it by 2, you get 2 failing scores. How can that be? 2 failing scores end up to a passing score. So because of these things, we talk about counterintuitive results. That's what I call them. There are ad hoc solutions, have been a lot of them. For instance, capping operations using minimum or maximum of scores, and the arithmetic mean of scores, which also produces artificially score between 0 and 100%, but it doesn't solve the underlying problems. Does that mean that the concept of percentage scores is basically flawed and useless? No, it's not. But you have to define the rules of crazy arithmetic, we call them. Then you can avoid all the problems. For instance, if you look at the box, you will see the definition of crazy sum. So it is different from just adding P and Q. It is a formula which gives always a proportion, a percentage between 0 and 1, or 0% and 100%. Once you have this, you can derive all the properties of addition you need. They are very similar, but a little bit different from the usual arithmetic. You can define crazy multiplication, which is fine. And you can also define the inverse by multiplying by -1. And once you have these 3 things, addition, multiplication, and inverse, you can define crazy arithmetic means and scoring rules which behave correctly and intuitively. Now we are interested in group peer assessment. For that, you need a scoring rule, and this scoring rule will be endowed with two parameters, an impact parameter and a tolerance parameter. The impact parameter moderates the effect that the peer rating will have on the group score, and the tolerance parameter restricts the final student score to a specified subrange. For instance, the range from 25 to 75% on the percentage score. Now there are many scoring rules which you could define having this creative arithmetic. But our favorite creative arithmetic scoring rule to start with is a very simple one with an impact of 1 and a tolerance of 2 and a simple function. It is a simple linear function of the student rating. There are two more parameters. The group score is a kind of parameter, but we also have a vibration factor on it. I can't go into the details. I invite you to look at our paper. But what is important and nice for this scoring rule is that the range of possible scores for the students are now symmetric around the group score. So there is a possibility for students to go a certain amount, let's say 30% below the group score and 30% up of the group score. That's very nice. But as I said, it's not the only possibility. So the conclusion is when you use the quasi-arithmetic rules of scoring, you will have no problem of working with bounded scales, for instance, the percentage scale for group peer assessment in software education. So that is my summary of our research.
Okay, thank you. Thank you for the short summary of your paper. To lead off our discussion today, I think Jose Rocha, I'm sorry if I'm pronouncing your name wrong.
Sure, but it's fine.
Jose or Jose?
Jose Rocha.
Jose. Jose.
Because it's Portuguese. Well, first of all, thank you for this paper. It was quite interesting. I got a little bit scared when I looked at all the math that it involved. It appears to me that this would be particularly useful if you use percentages all the way down, even when scoring all of the individual exercises. Is that the case? So if you'd have an exam, you would have, if everything was rated in a percentage from 0 to 100, you would, in order to sum and get to the final note, you'd simply replace the weird operations that we normally try to do, or the weird scales that you use for each exercise that we can sum. You would replace it all with the quasi-sum in this case. Is that it?
That's right, yes. I'm using this quasi-sum and the other operations that derive from it, follow it from it. But I want to say one thing, it isn't necessary to use a percentage scale. You may start with any bounded scale. Yeah. It will be internally in the software we are developing now. It will internally be transformed into a percentage without loss of any information.
So you can basically use the same scale across all subdivisions of the exercise of the exam, the exercise, the work that you're doing, and then it guarantees consistency throughout the whole exercise, and you just need to replace them with a quasi-sum or one of the other quasi-operators concerning the parts.
That's right, but you don't have to use in all parts of the exercise, I mean the assessment, the same scale. So it may be that the tutor, who is mostly providing the group score, is using one scale, for instance, the scale from a 60-point scale in UK, and that you say for the students, we use a somewhat easier scale, 1 to 5 or 1 to 6 or something like that. And all those assessments, so the group score and the student scores or student ratings can still be summarized in one score, one final score for the student.
Okay, thanks. I have another question. As I looked in the formula that you propose with the impact parameter and the tolerance parameter, I was wondering if there's a parameter or a way for normalizing group assessment scores. Because you can have groups that assess themselves with particular tendencies, and others that have quite a lot of variance on how they assess
yes.
other members.
I see what you mean. Yes, that's the impact parameter. We use the impact parameter for that. So it is well defined. Of course, you could do a lot of things in standardizing or normalizing things like that. But we thought it would be most easy for the users of such a device like we have developed to have a single parameter which captures all these information, all these possibilities of strengthening the impact of the peer ratings on the group score or reducing a little bit.
Okay.
What would be important, we think, is to do this for all students at the same way. So it would not be correct, we think, to do it in this way to have a separate parameter, impact parameter for student 1 or 2 and 3 and 4, etc.
Okay.
That would not be correct. But if you see that the whole group is in some way very dispersed, then you might say for this group, we adjust the impact parameter.
Okay, thanks.
Of course, it would be necessary to do some empirical research about, in many circumstances, how often these kinds of dispersion is too large or too small. For instance, I know from my own college, my own lectures that some groups say we don't want to make any differentiation within our class. Just give us the group score.
Yeah.
Okay, of course, then the whole game is over. But that would be possible. Of course, also if you don't say that, or also if the students don't say it, but you see on what they give back that they have done a coalition forming, as it's called, and they gave all the same points to their colleagues, to their peers in the group.
Yeah. Okay.
Well, that is not what we hope, because the whole exercise is in developing an instrument, group peer assessment, in which is it possible to give different students different scores in a systematic way, which can be traced back by all who are interested in it.
Thank you very much.
I thank you. Okay. Yes.
That's it for me. No, I don't have any further questions. I'll leave the.
Okay. I see Bastian raising his hand.
Yes, thank you. I'm sorry, but maybe I'm still too tired. But can you say in like a sentence that is as short as possible, why?
That's very good question. It's going back to the start of my lectures. I have to formulate it in one sentence. Well, there's only one reason for it, actually. The reason is that the faculty or the administration at the university wants to see individual grades and not group grades. It would be no problem to produce group grades because that is done by the tutor on the basis of the material he gets from the students, the group work that is done. Yeah. Yep. So it is a product assessment, what comes out of the group. And you could say, of course, okay, when that comes out of the group, and if we may assume that all the members are participating in the group in a very motivated way, then they all get this grade. But that is not allowed, that is not accepted by the administration. They want to have individual grades.
Okay, so the context of the problem is we have group work and we are assessing fairly the students in the group work. Okay, now
that's right.
Okay, now I'm getting you, because the entire time I thought to myself, okay, so one student gets a grade of 20 and a grade of 70. compute the average and be done with it, right? But okay, now I'm feeling it. So
okay.
then I guess I guess my follow-up question then would be, all right, so if we like this implies to me that there's a sense of absolute achievement when there, like, I would argue there isn't one. I would argue then, rather than mathematically and absolutely assessing someone's score, like you were 42% successful in this project, right? You were 78% successful in this project. I would argue that, you know, perhaps a way of dealing with that is to achieve the individual, to measure and to assess the individual knowledge gain, the individual learning. What's your thought on that?
Yes, if that would be possible, we would do it immediately, and we would forget about the group peer assessment techniques, and also all the colleagues all over the world who are working on it. No, the problem is, if the group gives the results to the tutor, to the instructor, who has to calculate the group score on the basis of the work done, actually done.
Oh, so you're actually, so basically you're saying you don't care about how the students behave, you don't care about their project experience, but here's the artifacts, and that's what we're grading on.
Yes, we are interested in that, but we are also interested in the individual students working in a group. How did they do that? And there we have formulated 10 different criteria on which you can measure that. The problem is, we as instructors can't look so deep into the group work that we can know how it works, how it has worked up during a whole semester, or maybe a whole year. So what we do is, and that's a little bit tricky, you can discuss about it, it's a philosophical issue. We give this task to the students. We say, well, the student did the work of working together, and they got the experience. They know the best how their mates in the team worked on it, and if they had some profit of it, or that they have to do, one student say, I had to do it alone. And they just sat next to me and looked how I did it. So what we do is we delegate this task, this part of the assessment, to the students, who come up with peer ratings, which can be done fairly well if they are trained a little bit in it. And we use these peer ratings to accommodate the group score. That is the whole trick.
Okay, I understand. I have more comments, but perhaps later, in the interest of time. Thank you very much, Paul.
Yes, okay.
Thank you very much, everyone who took part in this session about grading and assessing students' achievements. In the interest of time, I'd like to turn over to our next session, which I assume is happening in this same Zoom room, seeing that a lot of new people have come in. I'd like to turn over then the floor to Stephen and, oh yeah, just to Stephen, not.
Thank you very much.
Thank you.
Thank you.
So thank you, Patricia. So this is now the session on software development processes. Welcome, everybody. We have 4 presentations, and we're going to do them in the flipped format, as you may have previously experienced. And that means each presenter will have 3 minutes to talk from their teaser slide about their subject, after which a named discussant gets to ask the first question. And I think after that, it's whoever raises their hand. And I believe you will see in the, if you click on the participants bar at the bottom, there's a way on the left, a little hand raise. You can do this so that it's easy to see. You also may get away with just raising your hand in your picture like I'm doing now, and that could work also. So the software development processes are a very interesting and key part of CSEE&T, and part of what distinguishes software development from computer science. And we've had an interesting history trying to do things like add software development on top of computer science in many of the programs that you're all a part of. Famously, in one paper long ago, Tim Lethbridge said he saw the glazed over eyes of his students when he started talking about some of these subjects. So it's very brave of you all to be participating in this, and our authors have come up with some ingenious ways to present these that capture the students' interest and so that they get to see the value. And in one of the papers, it's to people who are already in industry. And if you read the paper, you probably felt the difference there in, the automatic sense of value that they get. But anyway, so there's a theme here that goes way back in CSEE&T history. So with that, I'd like to turn it over to Pedro Marquez and Marcelo Schatz for the first paper, Requirements Engineering Out of the Classroom, Anticipating Challenges Experienced in Practice.
Hello, good afternoon. Thank you very much. Thanks everyone. Well, good afternoon here. There might be night, might be morning. I don't know. I'll just share my screen here so we can see. So our work was, can you guys see, just to confirm?
Yes.
Yes, okay. So our work was done based on a principle, basically, which was uniting practice and theoretical classes inside of a requirements engineering course. This is done, of course, by many ways. Right now, currently, by toy projects, or the professor kind of acts out like he's a client, and then the students act as requirements engineers for a project, and then they try to come up with solutions, and then a prototype, maybe, if the course allows it, to get their final grade. But our idea here was a little bit different. We wanted to see if we could make this through a real project, a project that the university needed, and then unite this, students from the university, the professor from the university, and then a project for the university, all of this in the requirements engineering course, so that we can have, the best of both worlds. We can have theoretical classes and then actually apply them in a project for the university, which is something that we all could get points from, because we're going to use the project was a website for the Institute of Mathematics and Statistics, so we all would use the website in the end of the day. So it would be fruitful for all the students and us as well to get the website going. So we managed this by one of the professors from the institute. He already had this idea to change the website, because the website that we knew there were some problems, but he was the first one to actually contact the computer science department to actually present a project to, no, let's do this, let's finalize this, let's put a website on the air. And he came up to Professor Marcelo, and he had this idea of incorporating this into the requirements engineering course. So during the course, we actually had theoretical classes, and then followed up by tasks that were practical tasks to, build use case diagrams, complete a part of the requirements document, execute, some new advancement in the prototype. So we all had, the theoretical part, and then we had immediately after a practical task to do. And we had the stakeholders, and we had interviews with them, we had brainstorming sessions with them, and we had to present this prototype not only to the stakeholders, but also to the head of the department, that he wasn't one of the main stakeholders of the project, but he was very interested, since the website was for the institute. So it was in his interest to have this website be well done. So we came up with some thought-provoking considerations, just to get the question started. I maybe you guys can use this to formulate a question, but maybe use this. So we have the time management issues with this approach. There's the amount of extra work that you need to do, because it's not just a theoretical class. You need to, schedule meetings with the stakeholders, which is something difficult, because not everyone has the same schedule, so that's complicated. The students' commitment, because the class needs to be balanced. You can't just put a lot of tasks so the students get bored or they think they're being overwhelmed by this. And then the problem of a real project. We want to make it seem like a real project in most cases, but then the students taking it as a real project is something completely different. That's why here we tried with a real project, really real project, so we could see what would happen at the end of the day. And the assessments are, this must be done by a purely theoretic, technical viewpoint. Do soft skills play a role in this? Because software engineering has a lot of soft skills in play. It's not like just sit down in a chair and then go and make a program. And should they be used as a bonus or as a part of the grade? And if currently, because of the coronavirus, this might come into consideration for some of you, the remote scenario, how it would change, how things would be different right now, or in other semesters that this class would be offered remotely.
Thank you, Pedro. By the methodology we're using here, our first discussant is Franziska Dobrikite, who is also our next speaker. So,
yes.
Franziska, if you would like to
sorry,
ask a question.
I'm having a bit of trouble here. Sorry.
No problem. So thank you, Pedro, for your nice introduction. Can you hear me okay?
Yes.
Yeah. I really like that I got to hear and see all of you in your little video. And we actually have used a very similar approach in a course we are teaching at my chair in our institute, where we try to teach multi-team agile project work. And we usually look for some project inside our institute that can be developed by the students. And it's actually quite a lot of work after the course to actually
did it cut there too?
I think we lost your audio.
Did we lose Franziska?
Yeah.
It seems so, yeah.
Oh dear.
I think it's lagging.
That could be.
Yeah. Well, I can't hear her at all, actually.
Yeah, with Zoom, all things are possible here. Okay.
Someone else have a thought?
Yeah, Francisco, we apologize. We can't hear you. So anyone else, please ask a question. And,
the question's in the chat.
Yeah, okay. Yeah, look at the chat.
So, okay, give me a moment. How do I go? Oh, here it is. Okay,
so she's asking, have you marketed your prototype? And if so, how easy was it?
Right.
So marketed the prototype. I don't really understand what you mean by that, but
turned into a product for profit or for public use of some way, shape, or form, I guess.
Yes. So we can't actually turn. You mean the website, right?
Yes. Once the website's finished.
Yeah, so the website, we can't actually sell it because the university is a state university, so it's property of the state. So we just send it to the students and to the faculty saying, look, there's a new website. Recommend to the students to use it because now there's way more information inside of it, so that questions that new students usually have, freshmen usually have, they can use the new website because now there's more information there. So we it's more a website to produce information for the students more than a project to be sold or something. I'm so sorry. I don't know if that answered your question.
Can I just add some quick comments?
Yes, sure.
Here I'm Marcelo. I'm Pedro's professor, and as Pedro said, we offered it to the institute because it was required by the previous board of directors. The board of directors recently changed, and we are trying to make this work because the current version, which is now online, is not the actual version that is presented in the presentation, that is in the video presentation. But it depends on some additional work from the technical staff. But yes, we turned it into a product, but not for selling. That's it.
Okay, thank you very much. Additional questions?
I think Francisco tried to say something, but
yes,
yeah, I think there was
online,
some lag. I couldn't.
Go ahead.
Francisco, could you please type it again?
Yeah, I don't know if the lag is from there or from Zoom. You know, this stuff happens.
She said her question was answered.
Yeah,
okay,
I have it open here.
All right. So anyone else? I'd like to add that I thought it was very, very interesting that you brought the students in and made it a student-centered thing by virtue of making it a project they were inherently interested in. And I think there are probably other university projects around that we can do that with. And that does give them the sense also of playing the client somewhat, as opposed to just being the person who has to do what the client says. And that might be an initial way to spark their interest in this. So
yes,
I
absolutely.
that.
That's one of the main points that we wanted to convey with this project. Yeah, absolutely,
Yeah.
perfectly.
Okay, well, let's go to our second paper then, which is by Francisca.
Multi-team agile project work, and we usually look for some project inside our institute that can be developed by the students. Hello?
Okay.
And it's actually quite
A little bit like entering the matrix.
after the course to actually.
It's possible there's maybe somebody playing something on YouTube from another talk or something like that.
No, that actually was my question from before.
Okay.
I don't know why it's coming through
somebody,
now. I'm hearing it myself.
It's because somebody was watching the YouTube version of this and they had their microphone on and it was coming through. We saw that yesterday.
Okay.
Oh,
it's happened.
okay, yeah.
Okay, well, let's go on to Francisca. So Pedro, if you would relinquish the screen sharing.
So just stop share here, right?
Yeah.
Okay.
And Francisca, feel free to show your teaser slide and begin talking about yours.
I'm trying. Can you hear me okay now? Does that work? So I called in via phone now?
Yes.
Yeah, it's perfectly.
Yes. Okay, and then do you see the slide? No, you see the wrong window. Okay, let me try to figure this
It's a
out.
nice shot of me.
Yeah, I don't know how this is supposed to be working. Let's see. I think I used the right screen. Maybe I didn't. Let's try again. I'm sorry. Lots of issues today, even though I've been using Zoom like forever now. Let's see if this works.
Yes.
Can you see the slide now?
We can see something that may be a slide on your end.
Oh no, I'm sorry.
It's problematic.
Yeah, apparently my connection isn't good today. So I'm sorry for that. Maybe someone else can share my teaser. I don't know. I'll talk about it anyways.
Yeah.
So I've been
unshare your screen if you would.
Yeah, I can. Wait a second. Unshare. Okay. All right. Unshare. So what we have done is we have developed a sort of process framework that tries to combine design thinking and agile development and lean startup techniques, and kind of look at which of the techniques make sense at which point of the development workshop, the development process, sorry. And then we developed a one-day training to try and teach our ideas to industry partners. And then we ran this workshop at Palo Alto, and then at Potsdam in Germany, and also in Ireland with different industry participants from different companies, ranging from medium-sized and small companies, even startups, up to enterprises, and kind of collected feedback on the ideas and on the workshop. And overall, the participants we had in our workshop, they had a positive experience. Most of them became aware of new tools. So since we were addressing software practitioners, software developers mostly, and managers for software developers, most of them had experience with Agile before, but did not know a lot about design thinking and lean startups. So they learned some new tools from these approaches. And all of them agreed that the combination of these approaches is applicable to what they are doing in their companies, and that they take away some beneficial tools. Yeah, that's my short summary.
Okay, well, thank you very much. And our discussant, our named discussants are, let's see, Pedro Marquez and Marcelo Schatz. So Pedro, we know, is here. Feel free to take it away on the discussion.
Okay, so I really liked your project. It was really amazing, you know, uniting all these techniques into just one workshop and seeing them work together. It was really interesting to read about. I have some questions here. So you mentioned that the one-day workshop seems, I'm quoting here, one-day workshop seems sufficient to introduce the basic concepts we aimed for. But there was still some time pressure that was giving like a negative response in one of the graphs.
Yeah.
So you said also that no one mentioned that our longer running workshop would still be, well, no one mentioned this longer workshop. So I'm wondering if you think that a 2-day workshop or maybe a 3-day workshop would be better, just to further digest the content so that everything wasn't just packed into a 1 day. Or do you believe that this pressure actually helped the participants to actually come up with more ideas and more solutions? Because I know that one of the participants actually mentioned that. So.
Yeah. So I think the time pressure, even with the participants, was a double-sided thing. So some liked it, some didn't like it. Some actually didn't like it in the beginning and then liked it at the end. So that was very funny. And I think, yes, a 1-day workshop is very short, but then for people working, also having 3 full days of something that is not the actual work is usually a kind of hassle. And that's why we said we're going to start with a 1-day thing. And yes, I think you can give them even more, you know, tools by the hand and have them get a deeper understanding of things if you have more time, and maybe make a 3-day workshop. But what we wanted to do with this 1-day workshop was to just install the idea of these things can be useful even though you might have not known them before. And even little things like just using 1 or 2 methods from one of the approaches can already help you along in what you're already doing. And so the basic thing of giving them the idea and giving them a couple of tools that they could use in their own company, I think that's achievable in the 1 day. But I think if they were going to use this whole process in their own company, there's more time that they would need to process everything and then think about how it applies to stuff they're already doing in their company. So yes, also you can do longer workshops with a different goal, I would say.
Okay, I get it. Thank you. So I have one more question. So I don't know if this was possible to assess during the process of the work, so that's okay if you have just an opinion. But how long was how big were the groups actually? Better yet, because you mentioned that were like, I think 32. So, but they weren't actually everyone into one day, right? It were multiple days.
It was three different workshops at 3 different locations. One location was 2 teams of 4, one location was 3 teams of 4, and I think 1 of 5. And then the other one was, so the teams were about 4 to 5 people. And then we had 1 with 2, 1 with 3, and then I think 1 with 3 again. 3
so,
teams. So, yeah.
So the question was actually, if this was to be applied like in a very big company, so would this be a problem? Because, or you would just like divide into, I don't know, 5 or 6 teams of 5 or 4 participants, and then would just conduct the same way, or you would like divide into 4 or 3 teams of more people, and if that would pose a problem to this methodology.
I think there's 2 things that would be important. One is the team size. The more people you have, the longer the discussions take, right? So you don't want the teams to be too big. So we found 4 is a good number of people, so that the discussions don't get too long and you can achieve them in the short time frames we're giving. And the other thing is, if you have more teams, then you also need to have more coaches or facilitators, so that each team can have an instructor next to them that can help them out if they're stuck with a method or something, so that they don't lose too much time, and someone can directly help them and intervene.
Okay,
But then I think you can scale.
I see we do have a question from Christopher Bowl.
Hi, yes. So years ago when I was doing my PhD, I did we had computing design and management, and we had people from all these disciplines coming to a melting pot. And I've been working quite closely with all of these people since then. One thing that has come up on many occasions is that it takes a long time to learn how to do designerly thinking, not just design thinking as the technique. We're talking maybe in the order of years. You've got to practice it, and obviously this one day a workshop won't do that. It is an introduction, so and it's something is better than nothing. How do you avoid a business from essentially seeing this as a tick box exercise of great, they've done some design training, done, moving on?
Oh yeah, that's a good question. So when we ran the workshops, we kind of focus on telling them that this is just an introduction, that naturally they would have to adapt things to what they're doing, that they would need more training or train people in being coaches or facilitators for these kind of activities, and that they need to practice things to become better at them. I think you can't really avoid someone making a tick and saying, I've learned this, I'm done. So we just try to make the point come across that, you need more work. It's going to be different in your actual work settings. You can contact us if you want help with that or have questions, and you can look for coaches, facilitators in your area that can help you with that as well.
Okay, let's see. Patricia Brockman has a question as well.
You're muted.
Go ahead.
Sorry, can you hear me now?
Yes.
Okay, sorry about that. I really enjoyed your paper. I thought it was very interesting what you did. And at the end, you talk about 3 different workshops in different places, mostly in Western cultures. But did you notice any difference, for example, between the workshops you did, say, in Palo Alto and in Potsdam?
I think the one we did in Palo Alto, we had some more design people in there. So if you look at the participants table, we have a couple of designers who come from a design background. They usually had some experience with the design thinking or more designerly methods. And that wasn't the case in the Germany and Ireland workshops. So it was more developers and development managers. But other than that, it felt pretty similar, I think. I've done design thinking workshops with like Asian groups, where you can see that, for example, it is hard to speak against elderly people. So we do know that cultures can make a difference, and we didn't experience that in our workshops. So that is an open question if if you would have adapt things for a different culture. Yeah.
Okay, thank you.
I see that Patricia's colleague, Moritz Marichki, also has his hand up. If you'd like to unmute yourself and ask a question.
Thank you. Yeah, if I can manage in 2 minutes. So thank you. This was interesting. And I had a similar question also, but I have a separate one, which I was curious about the minimum viable product that you were talking about in the beginning of the workshop. How is that determined? Was that done during the groups, or were there some like restrictions or guidelines given for that?
So the concept came from Lean Startup, and they're trying to evaluate sort of which are the features we need to do first so that we can have initial customers that are willing to pay for these features. So they just need maybe a little thing and they're already giving us some money without having the full product as we kind of envision it for future cases. And that is where the concept is coming from. But then if you look at like success stories, they can also be not even products where they kind of hand did whatever service they were offering without AI and stuff and just do it themselves with manpower. And that could also be a minimum viable product. So it kind of, there's two sides to this, to this MVP, I think. One is more of a prototype black box where people can pay for the service and receive the service, but it's not actually developed as a software, but sort of done in the back. And the other one is a software that has a sort of minimalistic feature set that is already working. And that should be determined within the team and together with either the customer or the product owner, depending on how your team is set up. Does that answer your question?
Yes, thank you.
Yeah.
Great.
Okay.
Okay, thank you very much. I see that it's now 9:30, which makes this the very first software-related project ever to be on time. So our next presenters are Moritz Marichki and Patricia Brockman, who will be talking about teaching distributed requirements engineering, simulation of an offshoring project with geographically separated teams. Go right ahead.
Okay, thank you very much. Is the slide visible, I hope, the teaser slide? Or not
Yes.
Yet? Okay,
yes.
okay. So if I switch, now it's gone. Do I understand correctly, or?
No, we can see it just fine.
We can see
it.
Yeah.
Okay, okay, great. Right. So this project was. Sorry, gather my thoughts. Okay, so thank you for joining. And so this is a joint project between Professor Brockman and me and Professor Krisanov, also in Japan. And it's a master level collaboration in global software engineering course. So between our universities, Ritz-Mekan University and the Technical University in Germany. This has been running now for 3 years. We actually the 4th year right now, if I see it correctly. And actually we had one class today just finished. And so this global software engineering course, we usually try to find a real customer in Japan to ask questions about requirements and to have a collaboration and also ask questions throughout the semester. The structure of these courses usually that we have a few teams and usually about 4 teams and they're distributed half in Japan and Germany. And usually the numbers were, I think, 20 to 20 students in Germany, about 7 to 10 students in Japan. But for this particular semester, we had 25 students in Germany in the beginning and only 4 students in Japan. So we had to quickly kind of adapt to a new structure of the course. And we decided on having 4 competing teams in Germany and a separate requirements engineering team in Japan, which kind of took or collaborated with each of the teams. So just 1 team in Japan and 4 teams in Germany. And we usually do a before and after questionnaire to see several dimensions regarding to how students see their perspective of what would be most influential in global software engineering. So something like geographical distances, language differences, cultural differences, what software tools are used. And we do this before and after to see if the experience of the software course changes throughout the semester. And we usually get some discrepancies, interesting one, between the cultures. And this time, although in Japan only 4 students is rather not statistically significant, but for some values we had quite some differences. For example, in the understanding of language differences were thought to be very strong in the beginning, but that kind of dropped. Whereas on the German side, this actually increased in the other direction. And often this kind of connected to cultural differences, we saw a similar trend there. Okay, yeah. I think that's it from my side. Yeah.
Okay.
Welcome.
Thank you very
questions.
much.
Thank you.
Patricia, you're deferring to your colleague, right?
Yes, yes.
Okay.
I'm deferring to my colleague Moritz, but I'm here to answer questions too, if there are any questions about the different sides of the project.
Oh, yeah. So we do have our lead questioner, Boris Ardish. I apologize if I'm not pronouncing that right, but
yeah,
please
it's
unmute
okay,
yourself. Yeah, go ahead.
I like the idea. It's a differently organized course. It's harder to do these things on the management side, but I think it's beneficial and interesting for students. You are not going to have many courses with this structure. I haven't seen one before, actually. But I want to more know about how successful were the student projects. The paper really doesn't delve into that. I mean, they had some requirements, and the process is harder because it's offshore. And I think in order to show that, you should also have them verify those requirements after the project is done being implemented.
Yeah.
I have also one more question, but I'll ask later.
Do you want to talk about that, Moritz, or should I?
Yeah, we I think might have different viewpoint, or not viewpoints, but how the course is conducted and also evaluated is different on the Japanese side and German side. So maybe I'll give a short comment, and Patricia, you can follow up. So the structure itself, we haven't put this one into the paper for this conference, but usually these requirements are, of course, documented and conferred with the customer at the end and see if they were fulfilled or not. So we had in that sense, a successful conclusion for the project itself, but we haven't indeed looked closely on that side, I believe, in Japan. I'm not sure, Patricia, if
okay.
You have.
Yeah, this semester was a rather unusual semester because we had such an uneven number of students on each side. Usually what we do at the end of the semester is each one of the project groups holds a project presentation of their prototypes in front of the customers. So I think this last semester, one of the groups created a prototype with Raspberry Pi and presented that to the customers. So we have a number of very different solutions. And this semester we had 4 different teams, each competing with their own solution in front of the customer. So usually it's a matter of the customer who has to decide which of the competing teams has fulfilled the requirements that they gave us to the best of their abilities.
Yeah, I understand the process more clearly now.
Okay.
Another thing as well, I couldn't really figure out what the students, I mean, how is the development paradigm? What is the development paradigm that they are using? Are they going to complete the requirements first, then move on to the implementation? Because if you do it waterfall style, then the student in Japan, I mean, that course will be very front heavy, right? The requirements are done, then essentially that person will be done. Or it's more like a mixed up agile, maybe with like iterative development kind of paradigm.
Right. So the requirement team is also in charge of establishing requirements, but keeping in contact with the customer. So in this case, it was for developing a laboratory management system. So in Japanese universities, it's quite common to have one professor guides one laboratory with several students, and to see like who is there and participating or joining. And so this concept was not is not readily understood in or was not readily understood in the German side or German teams. So this information had to also be communicated, and basically these things, keeping contact with the customer, was a ongoing process throughout the semester.
Yes, I guess we could say that the Japanese teams, each one played the role of the product owner for each of the competing German teams. The Japanese product owner interfaced with the German team and also with the customer in Japan. They were responsible for gathering requirements, for trying to make the requirements more clear, and for clearing up any sort of misunderstandings between the two sides.
Okay, other questions? I don't see hands up. Okay, well, thank you very much. If you would relinquish the screen, we will let our last presenter, who's already engaged, talk about creation of a serious game for teaching code review and experience report. So please go ahead.
Essentially, we see that the code review process is a beneficial process when it's applied correctly, but in the software engineering curriculum that we have interacted with, either for computer science or computer engineering or software engineering departments, this process is often overlooked, and we want to do something explicit to get rid of that knowledge gap between students who are just starting in the industry and freshmen who just entered the university. So we have developed a serious game, for this process from scratch. I actually provided a diagram for the whole process of this study. So we designed and created a prototype for the code review serious game. But this study considers the prototype. We had some learning objectives, and in order to realize those, we went ahead and created a prototype. But we are not, at this point, we are not sure that if it is usable as an in-class activity. So we had a preliminary experiment with some higher level, mostly master level students, in order to verify that the game and the evaluation material we prepared was working, it was clear, understandable. So this study focuses more on that. I should familiarize you with the game itself and the evaluation material. So the experiment that we designed starts with a pre-survey, has asked for some demographic information for their previous experiences, if they are familiar with code review. Then we prepare the code review related quiz, which also has like knowledge theoretical questions, who does that, what should happen when type of questions. Also there are some, since code review is all about like being able to find defects, smells in the code, it also has some programming related questions. Then there's the main game content. It has a tutorial and a couple of levels, and after the game is complete, then there will be a they then take essentially the same quiz again, so we can directly observe the differences here. Then we have a post survey for their feedback and how everything was perceived. The game flow goes like this. While you are playing a level, you are starting a level, you will be presented with a piece of code that we injected with some defects. So that process is static, so the code is set beforehand. Then the person will start reviewing it. If they can't find defect, if they can't find any defects in the code just yet, because there are some, we have a checklist for them. They can use hints, so some helpful features there. Then if they can find the reason, as a part of the mechanics of this game, they also have to determine the reason of that defect from essentially a defect taxonomy. So categorizations, they divide up like a binary tree, not binary, but like a an array tree. Then at the roots, they have the actual reasons. So they are also learning how the defects can be organized and communicated. Then they find a reason and add it to a list. Then they repeat this process until they are satisfied that they think that there are no more errors in the code. Then they can submit it, and we can evaluate it and give them a score and some feedback based on their evaluation. Then, yeah, this is essentially how the game is played. And after the gameplay and the experiment was completed, we also went up and did some interviews with the participants. We had 7 participants, 5 were master students, and 2 were senior students for the preliminary experiment. And in the interviews, we asked them to evaluate the questions in the quizzes and the surveys and the game levels themselves, because what we are trying to get out of this part of the experiment, the preliminary experiment, is that whether our material is correct, it's clear, and also if the students taught the questions in the quizzes, let me rephrase that. One of the key points in the interview question is that whether the gameplay would would provide them a different perspective, because they are going to see the same question twice, once in pre-quiz and once in post-quiz. And we asked them directly whether this question in the quiz would have a different meaning after the gameplay. We also tried to measure that and shed some dead weight, because the experiment took a lot of time. So in order to make it a viable in-class activity, we omitted some questions based on their feedback as well. And at the end of this process, we were ready for using it as an in-class activity. And this is not in the scope of this paper, but after we have submitted it, we have conducted an experiment, larger main experiment with 130 students or so, and its results are good as well.
Great. Thank
Essentially,
you.
Thank you.
Okay, thank you, Boris. All right, so we have our 2 discussants lined up to ask a leading question. Please go right ahead.
Okay, thank you very much. So this was indeed very interesting. I found it also important for future evaluation methods, and I especially like the you were saying that you used basically evaluation methods or a structure from social sciences to wrap the experiment itself in a quiz, and then again wrap that into a before and after survey. I was curious about the if the quizzes themselves, if you found if they could indicate if a learning objective was achieved or not. So you were saying about mapping learning objectives to that game design. Was it possible to see from these quizzes, or maybe in combination with the survey after comparing the results?
Yeah, actually, it is possible, but not in this experiment. Not in this paper. So this was like an improvement experiment, and after that, as I've said, we had a larger main experiment with students from 2 software engineering courses, and in that you can see that there are differences in quizzes. There are also some overlapping questions in surveys based on their confidence regarding code review related scenarios. And in there are also differences. And we went ahead and made a journal paper using the statistical or analytical data that we gathered from the larger experiment. And we are presenting its results, but it's not published yet, so it's still in review. But what you asked was achievable. I mean, I wouldn't say 100% clear, but results are really positive.
Okay.
Definitely looking forward to that.
We
may I have one follow-up question, or?
Sure. We do have other hands up.
Okay.
But yeah,
please go ahead.
But
yeah.
please
if
save,
time is left,
save
I
your,
will come back to.
Yeah, right. Indeed. So Ishti from Penn State Abington, if you would unmute yourself, please ask your question.
Thank you. Nice talk. Just wanted to know if you have a quick demo, or can you show us some example of the game itself? Like, do you give the code, or students come up with their code to find out test cases?
Yeah, actually it is available. The game itself, both the source code of the game and the game itself that we have deployed. It's a web-based project. Nice. So those are available. You can find the paper in this conference, and it has a link to a GitHub page. And in that GitHub page, because we have 2 domains for the project, we are also making additional game modes. So we have a stable domain and a newer test domain. And you should be able to find both of these from the GitHub page that is in the paper. Perfect. So you can try it for yourself.
Okay, perfect. Thank you.
Thank you. And Ben Reed, I believe you're next with your question, if you would unmute.
Yeah, so this sounds like a really cool idea. I'm curious if you've thought about using real, like open source bugs to provide content for your game.
Actually, that's the original idea, because creating content turned out to be a challenge as well. And what we were describing was the original idea. But the problem here is that we are trying to utilize this as an in-class activity. So it's not a tool that you should be able to finish it from start to end in about an hour for the gameplay part, I mean. What's hard about the open source defect is that they have a lot more context. So it's not just, our levels are like 150 lines of code that is very generic, very easy. They're in Java because it's a common language in our school. It's the first language that they are taught. But if it was a bug from an open source project, I would also I should also provide them like the related other files, what work has been done on that before. So essentially, it would have a lot more context. It can be done, but it can't be done just for any of the open source bugs in our context, because it might be too hard or context might be too little. That's
right. Yeah, I was I was considering that. I was wondering, kind of along context lines, have you thought about, or do you provide like test case failures to kind of prime the review?
Yeah, the current part, it only considers the reviewer's part. So it's simulating what reviewer does in the code review process. But for a complete code review game, it's not enough actually. So we are also making another game mode. Actually, it's ready, but we haven't had the experiment to try it yet. We made another game mode that's from the perspective of the author. So it starts when an author gets a review for one of their commits. So in that mode, yes, there are test cases. They can run the code after making changes and see how different feedback they get from the system, essentially, but not in this mode.
Okay, and Christopher Bull has a question. Please go ahead.
Yes, so my reading of the paper, it sounds like the code review is mainly on issue and error detection, which is very important. My perspective of code review is error detection and then communicating with your colleagues the issue and maybe then working through a solution. Have you done anything on that, or have you got any plans on looking at how to do those additional steps?
We are actually, I would call the aspect you described as something like knowledge transfer, if that's all right with you. Knowledge transfer among teammates during the review process. We don't directly have that now, but we are aware of that, and the solution that we have found, we also want to provide that. Actually, it's not, I mean, we had that idea. I think what should be done in that scenario is a multiplayer version. So they played as a team, then they merge their defects. They played separately, then as a team, they should merge their defects and submit a single list. And while merging, they can like vote, discuss. We also had an idea about that, but weren't able to realize it just yet.
Yeah, super. I look forward to this and all the other ones you've talked about. It looks very interesting.
Okay, let's go with one more question so that we have a small break before our immediately following session. Marcelo Schatz, please go ahead.
Thank you. So I was wondering, you use a specific taxonomy, or is the game flexible to register other taxonomies if I changed, let's say, the language of the source code, and I think that a different taxonomy fits better than the chosen one? How was this handled?
Yeah, actually, since we are using only Java, for our purposes, we have a taxonomy that is from a previous study that was created by mining reviews. It's another paper. The link should be,
I saw it.
Should be in the paper. We adapt them for Java. We adapted it for Java, but you can get the source code, make your own levels, change the language, and you can also you should be able to change the taxonomy that you are using. But not in the domain that we are providing. You would have to like fork the project and modify the source code.
And another quick question: how do you manage the scoring after developers discuss a defect that was found but was not previously registered in the game? Say in the context that I found something, it's actually wrong, but it wasn't pre-registered as a defect. How can you provide this? How do you handle this?
I mean, we try to keep the levels really simple, and while designing a level, we make a correct piece of code, and we went through it to make sure that there are no more defects in it. Then we add static ones by ourselves, so we would know where they are. But I mean, it's a human thing. We also made mistakes in our levels, and students pointed those out, especially in the larger experiment, because it's not the same thing when 2-3 people are looking at something and like 150 people are looking at something. Students also have found some defects. Our thing is to usually go and correct for those. So I don't think we are doing anything to handle that, unfortunately, because I wouldn't know how to.
Okay, well,
Thank you.
Well, thank you all very much. Thank you to our presenters, especially, and everyone. Please stay tuned for strategies and challenges, or whatever the next event is you're going to. Enjoy.
Thank you very much, Steve, for chairing. And well, we will just move on to the next session. I just want to point out the last session, the closing session, which will take place at about 6 o'clock Central European time, and we will start with the awards announcement there, and then continue with the keynote talk. So just if you are taking some time off in the meanwhile, just be sure to be back on time. Okay, thanks.
Thank you, everyone. See you.
Hello. Okay. Let's see. Okay.
Hello, Dawn.
Hi.
Hi.
How you doing? Okay.
Well,
Thanks
for being able to chair and to doing that, and for being prepared to do that. Well, the floor is yours. It's 4 o'clock. Thank you.
Yes. Thank you. Okay. I believe, thank you very much for welcome to this session on teaching and learning strategies and challenges. I'm just going to have people go in the order that is listed in the on the web page program. If you know, if there's any problem with that, please let me know. I see Alicia is here. And so I'll give her the floor. Do I need to, they can share screen and such? I assume, yes, looks like it.
Good morning, everyone. Or good afternoon or good evening. I don't know where you are. My name is Alicia Grube, and I'm at Smith College. The paper I'm presenting is called Reflections on Course Blogs in First Year. Now, why is this being presented at a software engineering conference? And the important part is that we want to understand how to connect what's called writing to learn with disciplinary writing. So in software engineering courses, you all do some kind of disciplinary writing where you have students either write requirements, design specifications, or even testing guidelines. And so we want to understand how to prepare students for your courses, but beginning in the first year. And so the question we ask is we wanted to investigate the impact of having students write course blogs on their perceptions of learning. So we're not measuring the actual learning that took place, but we want to understand whether students think they're learning anything. And so I'm going to skip my results and come back to them because I want to talk about my motivations and the reason why we're doing this study. So as I said, our primary motivation is to connect writing in the discipline with writing to learn. And these are considered two different types of writing for the purposes of education. But obviously our goal is to really understand, have students increase their understanding of course concepts, as well as to improve their writing skills. So we looked at measures about how these impact both non-native and native speakers. And the other reason why we're doing this study is we wanted students to receive individual feedback at scale. So there are between 400 to 800 students in this course. And so we want to understand how we can actually give them writing support in the context of CS2. And so all of this motivated our actual assignment, which very briefly was 10 public blog posts. And the reason why they were public is because, again, we wanted them to practice disciplinary writing where they're writing for multiple audiences in the context of CS2. We required 3 specific topics and gave students feedback on those individual weeks. So what is our actual results? In this study, we found really mixed results. So only a minority of our students actually found the blogs helpful. So this is not a showstopper. We need to figure out why this is only a minority. But we did find great differences between our non-native and native speakers. And we found that specifically for our non-native English speakers, doing the blog posts in CS2 helped increase their confidence in writing. And so we have various questions as to why that was. The students overall required additional feedback and higher feedback rates per entry. So they wanted to get feedback every week rather than every 3 to 4 weeks on their writing. And as well, this is tied in to have more support for non-native speakers. So they want sentence level clarifications and corrections, in addition to broad the scope and flow and arguments within their blog. And so finally, as I said, our original intention was to mix this idea of disciplinary writing as well as writing to learn. But as a result of this study, we found the most important thing was that this is extremely difficult to do. And what we're actually recommending going forward, even if you're planning to use course blogs, is to separate writing in the discipline from writing to learn, but have both in the same course. So we could use things like tickets out the door, 1-minute surveys, or simply reflections to help students to learn, but separating this from having public writing or writing in the discipline. So in conclusion, we think that there's still an opportunity for blogs to be used, but we need to clarify and really tease apart these requirements. And I will take questions.
Let's see. Ben Reed has his hand raised.
Yeah, so I really like this work, and I was hoping it would be more successful. I'm curious about because sometimes the perception of learning differs from actual learning. I know you had reviewers. Did the reviewers think that the writing improved?
Okay. So by reviewers, I think you're referring to our teaching assistants that were trained in reviewing the specifics of the blogs. The really interesting finding we found was that like only 30% of our TAs thought that the blogs helped students understand the concepts better. They didn't think that it improved their writing at all. But I think that is kind of this conflict or this tension that we had in the assignment that we didn't know until we really studied how the students felt about it. But what we found interesting is that from the point of from a pedagogical point, 70% of our TAs said that the blogs helped them keep in more contact with the students' understanding. So the students that evaluated the blogs were the same TAs that were the lab TAs. So they met with the students every week. So by reading the blogs of the students, they could more easily identify which students were struggling in the course and actually give them more help in lab. So it was a tool that could be used to diagnose students, but they didn't actually see improvements in their writing. Great question.
If I may, also, did you use any cheating detection, like plagiarism detection tools?
To detect whether students plagiarized in their blogs?
Yeah.
Okay, no, we didn't, and the students were required to create their own blog, either on Tumblr, WordPress, or Blogger. And so it was all public on the internet, and so we didn't actually use any of the detection software, such as Turnitin or something like that. And it was more that the TAs were cognizant of whether they believed that the student actually wrote that, because they were meeting with them every week and talking to them, and so they could match the students' understanding with their opinions. And a lot of times it was actually they were writing reflections on their learning in the course, and so if it didn't have to do exactly with what they were talking about in the course, it wouldn't make any sense.
Right. Great, thanks.
Okay, anyone else? I don't see any hands raised.
So maybe I as the discussant.
Go ahead.
Clarification question. So regarding learning objectives. So these blog exercises, were they supposed to support some learning objectives of this course that you did the blogs in, or did the blog exercise have additional learning objectives?
The learning objectives of the blog were to support their learning of the CS2 concepts, such as abstract data types, recursion, etc. And so it was supposed to complement the learning that they were already doing in the lab. So in this course, students have to do a weekly lab as well as weekly assignments and this blog, and the blog was worth 10% of their grade. And so the blog was supposed to complement these learning objectives. The only additional learning objective, and it wasn't actually a learning objective, it was our objective, is would these blogs help students improve their writing or confidence about writing?
Okay.
Don, it's Nancy. I had a question, but I didn't see the hand raise thingy.
Sure, that's fine.
We've taught writing and software engineering programs for a long time. What I've noticed with students is that if they're using a less formal methods or less formal mechanism, they tend to drop into a Twitter type grammar and spelling, which is not that helpful. I'm wondering if you had a similar experience with the blogs.
Can you clarify what, so I'm sensing from your question that the assumption is that this is bad.
Using the, instead of you spelled out, just putting you.
Oh, okay, so not using full words.
Right.
Right, so they weren't required to write in academic speak. They were required to write in full sentences and use full words. So for example, we didn't penalize them if they used the word don't instead of do not. But there was an expectation that this is for a public audience and it should be in full words. So we didn't have the problems of Twitter speak at all.
Question from me. We experience currently that, for example, DeepL or also Google Translate really increased so much that you can write in your own language and translate the content at will. And it's nearly as good as if you would have written it yourself when you're quite okay with the language. So we currently make the experience at our company that we even can translate whole content automatically. So is it really still helpful in the shorter term range to be fluent in writing in another language anymore? Is it really relevant anymore?
Is it the question? If I'm understanding you correctly, the question is it relevant to be
Increase
fluent?
support for non-English speakers, because if I can translate my language, my German, my English isn't so good. I can write something in German and I translate it via DeepL, and it's fantastic. It's better than I could have written it. It's the case. Just try it out. It's fantastic.
Okay, it is my belief that for the students who wanted to enculturate themselves in an English-speaking culture, that this is important.
Okay. Yep.
Okay, let's thank you very much, Alicia, and we'll go on to the next speaker. And next on my list was Bernard Westphal. Is he here?
Yes. I'm here.
There you are. Thank you.
So do you see my screen?
Yes.
Okay, great. Thank you. Now, from one big cross-cutting issue, professional writing, to another one. Namely, my topic is to integrate the concept, the use of formal methods into an, I like to say, otherwise completely ordinary introduction to software engineering in an undergraduate course in the German context. So I should start, what do I mean by formal methods? And I use a pretty broad definition. The wording I use is by Björner and Havelund, who say a method is called formal method if and only if its techniques and tools can be explained in mathematics. Point. So there's a lot of techniques and tools in, like formal requirements and check for consistency, or formal architecture descriptions, like we heard yesterday, and checks for adhering to these prescriptions, like formal behavioral models for safety critical systems and model checking. And of course, the narrow interpretation is into like Petri nets, like deductive program verification. Now, my motivation for this work was that for reasons laid out in the paper, I felt, say, the risk that my today's students in their coming 20, 30, 40 years of career may come in touch with one or the other method in one or the other topic area. And so I wanted to say, build bridgeheads towards the education they receive then at their particular company, and introduce the concept of formal methods in this sense in different context areas. Now we are turning to the slide. In the middle, this is supposed to represent the course. Time runs from top to bottom. We have 4 topic areas. And the problem is, if we view this as a common software engineering introduction following a textbook like Somerville, for example, it's already pretty packed and filled. So where do we put the new complementing material? In particular, I should mention that I don't want to do a formal methods course. I want to do using formal methods in software engineering without sacrificing any of the classical content. And I see, this is the left-hand side here, that approach not so well supported by contemporary textbooks. So what many textbooks do, in my perception, is to go informally, go semi-formal, like what is the syntax, and then give an outlook to, well, this could be more formal and it could be analyzed, but we don't really go there. And what I want to do is to go to the right-hand side, so to jump to the far end of this subjective formality, informality scale, so that students, I hope, are able to interpolate what is in between. Now, the contribution is, say, a blueprint, a course design, how to do this complementation, and it's based basically on 2 ideas or observations. Observation number 1, the hooks to connect to are basically already there. So in the textbook, I find use cases, scenarios with sequence diagrams. I find structural software modeling like architecture descriptions. I have variants of state charts. I have testing concerned about programs. So what I do is I do, for example, the scenarios, the sequence diagrams, the structural and behavioral software modeling in a fully formal way. Now, how does this work? By a second observation, namely, these textbooks seem to use a lot of time for reading out intuition, reading out examples, and I use a properly selected, proper sub-language of, for example, class diagrams, do them fully formally in the time that I need not spare on intuition, and move intuition building, which is important, to exercises and tutorial sessions. And the paper proposes didactical reflections on which progression allows me to fit this all together without overstraining students with respect to level or overstrain. Thank you. Ready for questions.
Any questions?
I may have one.
My discussant. Hey there.
Yeah. Okay. First of all, thank you for your very good presentation and the very good paper. I really appreciate your approach because it leads to the applicability of these formal methods existing without overcoming with too much input. As you mentioned in this paper, there were several follow-up courses planned. Is there also somehow a student project planned based on the approach told that, for instance, you can do it somehow on a Scrum process where the students need to build up, for instance, a system and they need to follow up this formal way to go, or is this not planned right now?
Unfortunately, this is neither planned nor in place right now. And this is, say, not exactly to my liking, maybe.
Okay.
So the course came into existence by, call it, a reinterpretation of the existing module handbook. Okay, so I consider this to be a valid interpretation of my existing module handbook. And I have control over this course, but not the curriculum. Okay, so what we do have follow-up courses in the sense that there is a UML course that does formal semantics for, on the example of UML. There's a real-time systems modeling course using timed automata and duration calculus. And I basically observe, say, anecdotal evidence when getting students who do individual projects with us. Like there are 6 weeks projects, there's the bachelor thesis, there are projects in the master's. And well, we are a department which is into formal methods in this broad sense. And I consider, and I hear this from colleagues too, that we somehow do not completely fail in building this bridgehead to have a common ground of vocabulary in particular to start from and then go into individual projects, but not in the larger scale, unfortunately.
Are there any other questions?
Okay. Let's thank our speaker. And I see that for the next one, I see Andreas is.
Yeah, that's me.
Yeah.
Okay.
Yeah, go ahead.
So I can share my screen, right? Can you see my screen?
Yes.
Okay. Yeah, so I would like to present you our work of teaching novice supervised learning with autonomous model vehicles. Our experience is that, and I think it's not just our experience, that artificial intelligence is somehow a black box for the general public and uneducated or undergraduate people. So what we wanted to do is to create a workshop where we can teach the general public without any technical background, supervised end-to-end learning. And how we do it? We have our ADAS model vehicles. They are having several sensors and actuators on it. For instance, a LiDAR creating point clouds and so on and so forth. And with this model car and our approach, the approach is saying is consisting of 5 steps. We have first a very short theoretical introduction to artificial intelligence and the workshop environment, and then we then we start the workshop. Okay, we have our model vehicle, and we have here 2 tracks, and then the people starts collecting data. Because we are using end-to-end learning, where we don't have anything like prediction, creating word models and so on. In our approach, we just have our artificial neural network, the sensor data as input, and the actuator as output. So then we developed a workshop environment here. This is just one cut of it. And there they can easily configure this workshop environment, this artificial neural network. And then they can train it. And afterwards, they can deploy it on the model vehicle, and the model car starts to drive autonomously. And whether if this driving is good or bad, depending on what you say is good or bad, you can either recollect if your data sets are bad or not good enough, or you can just easily develop another neural network, and you can start the training. Because when we are using artificial intelligence, you will never fully know what this artificial neural network is actually learning. So if we have this model car driving, it might drive into a wall, and this is not good. To avoid this, we use our approach of dependability cages. This is a runtime monitor, and this looks up if there is a problem based on LiDAR data and a calculated trajectory. And if this car is coming too close to a wall, it stops. Yeah. Thank you.
Okay. Open it to questions. See if anybody is. Bernard has.
Yes, even though I'm not the discussant, I may go first. Andreas, you had this chart in the video, I think, of asking participants whether they learned something new. Now, people as well as neural networks can sometimes learn new things that you didn't intend them to learn. So my question is, did you ask these participants what did they learn? And first of all, what did you want them to learn with this setup and
okay.
Offer?
Okay. So first of all, what we want them to learn is that this model vehicle is driving on this course against or along a clock. So it's just driving, and hopefully it will not drive against the wall. Yeah, and this learning itself is based on the slider data and the speed and the steering.
Oh yes, this is the car. I am after the people, the humans.
Yeah.
So after the experiment, they said they learned something new, the humans. What did you want them to learn? And did you ask them what they took away from this exercise?
Okay. Yeah. We want them nearly give them a feeling about how artificial intelligence, in this special case, the supervised end-to-end learning is done. There is no real methodology. Somehow you can say, okay, for some use cases you can create somehow an approach, but in general there's no real way to go this. So, and this is for instance, especially for physicians, first of all, they find it really strange how to go. That they somehow just need to experiment. They create several neural networks, and first of all, they ask us, okay, where can I start? Okay, we said them, just try it out.
Okay, thank you.
Okay. Anyone else?
I have a question.
Yeah.
Perhaps Andreas, is this model car? I'm really interested in that, and I love what you've done here. And all of this speaks to me from way back ago when when I was in my undergrad, all the way to now. I love everything about it. I was wondering, I would love to do something like this with my students. Where do I get one of those model cars? Is it a custom product? Did you make it yourself?
You can buy one from Digitalwerk. In this paper, we set up a link where there you can buy one.
Okay. Okay. So
it's
not
not
custom.
Too cheap. It's not too cheap.
Well, thank you.
Marion, Don?
Yes, thank you for the nice paper. I was wondering, you talked about the uneducated public, but we have also in software engineering, or when teaching software engineering, not every software engineer needs to be a machine learning expert. But I guess nowadays everyone needs a basic understanding. And I was wondering whether you could see this approach also to be used there.
Yeah, okay. We applied this workshop at the ESG company, and there we have a broad width of experience. There were some computer scientists, but there were also some which have not to do too much with computer science. And we just wanted to give them a feeling about that artificial intelligence is also not magic. Sometimes you see, especially for in media reports, artificial intelligence is sometimes pointed out as somehow a magic, and this feeling we wanted to give people a more objective viewpoint on this topic. And of course, we have a model car driving. This gives participants also a cool feeling. Okay, I've done my own autonomous driving vehicle with artificial intelligence.
Okay.
I would have another question if nobody else wants to go first. Andreas, I can imagine the relation between the model car and a real car. Now, could you tell me a little bit about the relation between autonomous cars or prototypes that are on the streets now and these neural networks that you are using? How close together are they?
They are not too close.
Okay.
It's end-to-end learning. So normally autonomous vehicles are consisting on multiple elements. For instance, they do a prediction, creating world models, and so on. This is not done here. It's just we have the sensors. We have then here this is a convolutional neural network. This is classifying the situation, and then we have a full mesh neural network which derives the output for the actuators. Yeah.
Okay, thank you.
Okay, anyone else? Well, thank you very much. And we'll go on to our last speaker, Nancy.
This is Ann Conkey. I'll be presenting on behalf of both of us.
Right, I'm not the speaker, and it does a much better job than me.
She's great. She can interject, actually. So you're sharing. Yeah, I have, if you could share my screen. I've got a PowerPoint.
Okay, can you not share?
I don't think I've got, oh, I'm sorry, I see it right here. Hang on just, let me see if I can. I've got 5 screens. Oh, here we are. I want to make sure I share the right one. All right.
Okay, something coming up. Yeah, very
good. All right, see that? Okay, good deal. All right, so our paper is called Secure Sourcing of Commercial Off-the-Shelf Products, a Critical Missing Element in Software Engineering Education. Like I said, Nancy Mead, as well as Dan Shoemaker, and I, the 3 of us, formed a team to co-write this paper. Let's see if I can advance this here. Okay, so the premise of our paper is to make the academic argument that traditional software engineering education emphasizes good design, secure coding, effective testing. However, as many business applications are no longer developed as standalone products and require interoperability, many are already built and are available as commercial off-the-shelf products, and they're interfaced within a larger supply chain to create larger solutions. So one example would be the risk is when malware is inserted into a COTS product or potentially inserted and integrated into a larger system. This makes it very difficult to trace where it actually came from. So to support communities with best practices, to build assurance into the systems, the products, the services, the National Institute of Standards and Technology developed and published the Interagency Report 7622 that includes 10 principles for performance of communities of practice, and that's what you see here, the 10 principles. This particular framework seeks to equip communities with a set of repeatable and commercially reasonable supply chain assurance methods and practice that offer a means to obtain a greater level of understanding and control throughout the supply chain itself. So in addition to these 10 principles, a general process can be designed and structured that also includes these 9 critical tasks, and these were taken from the body of knowledge of information and communications technology, basically ICT, supply chain risk management. This was a book co-written by Nancy Mead and Dan Shoemaker a few years back. So, so from a software development lifecycle process, this process that we're proposing, we're proposing a modules for education. This would focus on the specification, testing, and acceptance phases of a project, given that the COTS products are already designed and developed. So this leads to our proposed instructional modules. And these are on supply chain risk management education using COTS products in particular. And so the 10 principles and the critical tasks have been interwoven to create a comprehensive context to ensure that students understand both best practices and a structure that aids in ensuring that the COTS products haven't been compromised through the sourcing products. So as you can see here, there's 4 different modules. They're jam-packed with obviously quite a few topics. This isn't all inclusive. However, the idea here is that you can break this into 8 modules. This is modular, actually. What the idea here is to develop a training program or a course at university that would include all of these different topics in order to help students really understand when you're sourcing COTS products, how to make sure that they are safe in the larger context of a larger complex solution. Okay, that's that. I'll stop sharing. These are all in the paper, by the way, so I didn't feel the need to read them. Let me stop the share here. Okay.
Okay. Any questions?
I may have one.
Yes, sir.
So very good job indeed, and I really appreciate your paper, and it motivated me to look at the curriculum, and motivated me to look at this work much more detailed than I usually do. So it was very well done, and I'm interested in taking at least parts of that into a course that I'm teaching myself, where I'm noticing that you know, selecting the right tool, the right library to use for students often is very difficult for them. So I'd like to know, I can't use it all because time, but I was wondering if I had to pick, let's say, a handful, how? You know what I'm saying?
Yes, I do, sir. I do. I understand. I actually worked in industry for 25 years before I transitioned into full-time academia. So I understand the very applied practitioner, because the idea here is for our students to be able to go into industry and get jobs. And I think the big thing is we want them to have skills. We want them to be able to code. But I used to actually work for a custom code shop, so to speak, in industry. But there's not a lot of companies that are willing to pay for custom code. So I think the big thing is, and I do realize that organizations have purchasing departments, but I think it's very important that in the event the purchasing function gets kicked back to the engineer or the person that we're teaching that's going to go into the industry, they really, I think if you could just kind of pull pieces out of here, I think what's important is for them to really understand the acquisition strategy and vendor management, because you want to make sure that the vendor has a solid scope of work as well as a service level agreement, so that when they're, because if you're getting a commercial off-the-shelf product, you want to make sure that that vendor is, it's really, you're picking a vendor at that point, not in addition to the product itself. So that vendor is what has some liability to make sure that that code is secure, and that it, of course, interfaces and it's interoperable to other things. So you want to make sure that that acquisition process, that the student understands how to make sure to pick an excellent vendor. And of course, not only understand the code itself, but to be able to work with that vendor to make sure, because that vendor is not going to give them the source code, but you want to make sure that they pick the right vendor so that that vendor supports that code and understands the liability of it being insecure in the event it is.
Right.
I'd add to that. In that context, risk management, I would say, is really important. And Astrid, most likely you are teaching risk management somewhere.
I am. Right. So right. Thank you. So both of those answers very, very helpful. It's in this particular course that I struggle with the idea of a vendor, because most of the time the things that the students pick in this simulated environment, if you will, are open source libraries that are available somewhere. But they run into the same problems that you have outlined in your paper. They run into the same problems, namely, okay, well, random security issues that that Gitbot doesn't necessarily fix right away, or even things like risk inherent in understanding the documentation of the library and things like that. So I'm super interested in taking the idea and applying it in an open source where there's no vendor, right? So right now I'm conceptually struggling with that, but I got to put some more brain into that, I guess.
The other thing I'd add, if you take a look at the paper, is all the course materials are available on the Software Engineering Institute website.
Indeed. Thank you.
Okay. Christopher Bull.
Yeah, so a lesson I learned several years ago was that when adding content to a course, you usually born out of good intentions, and it's usually brilliant. You always then have to consider, well, what's it going to be replacing? What are you going to be taking out of that course? So read the paper, it sounds fantastic. And there's obviously a lot of content there. So replacing is not practical on the scale of it, and even if you do the small bits. So, would this be a recommendation necessarily to have to create additional additional courses, and then who would it actually target?
I think you have to take a look at it in the context of the entire curriculum or that particular program, because you've got pieces in here. You've got project management that could potentially be taught in a different course, so that if you've got too much material and you've got to pare back to try to fit it into an existing course, you could look for areas in here that, like contract negotiations. Is there anywhere else in the curriculum that does, manage that? Maybe not. So that's one way to try to pare down and get to the actual topics that you want to cover. Or this is, well, the idea here was that this was a course in and of itself, only because there's so much content here. I'm not sure if that addresses your entire question.
Good enough.
Marcella?
In that case, I think it would be more likely to be an elective in a lot of programs.
Oh, that could be him. Gerhard looks like he's got his hand up.
Oh, I'm sorry.
Marcelo.
Okay. Can you hear me?
Yes.
Marcelo, please start.
Cool. Okay, so I really liked the way how the paper was structured. I read it and I found it really fantastic. And I like the intersection you made with project management practices. I myself had to dive into this whole component-based setting during my PhD. And I was wondering, what were the difficulties you found when teaching, when thinking about how students would understand those aspects that require more soft skills. Say this part that involves establishing contracts and this kind of thing that is not the focus of a computer science course.
You're bringing up an excellent point, because you've got, of course, the technical, which I love the technical. I'm more of a hardware networking, as you can see in my computer lab, but the soft skills, I was in management in my 25-year career. I got into the upper management, but you're absolutely right. It is very difficult to teach these soft skills. You need time to be able to do that. And when I say it's difficult when you have bachelor level students who maybe have never worked in a company, as opposed to master's levels who are working full time, and then here they are in your class and they can really contribute with their own job experiences. So that does make it, there's some, at a bachelor level, you would really have to explain a lot of what it is as opposed to the how. You can't get to the how if they don't know what the what is. So unfortunately, in that case, at a bachelor's level, you're really doing the what, but at the master's level and doctoral level, you could go in more of the how. That's how I would approach it.
Okay, perfect. Thank you.
Okay. Anyone else?
Yeah, me.
On his wonderful treadmill.
Yeah, I am, but that's not the issue that I wanted to point out. I think that would be a fantastic opportunity for lifelong learning and keeping students in contact with their universities. So I would propose this kind of, because you need some practice to understand why it's so important, and you need the realities of the organizations that you face, that you do that in a lifelong learning course where you always say 10% of the time that you have, probably a spare time, probably some Saturdays or whatever, that you really have these courses available so that you have exchange in both directions, and also having then the possibility to connect with the former students what they really see in industry and bring back a part of their knowledge. So that would be a fantastic addition to a lot of university courses, I would say.
That's an excellent point. I do have a lot of industry contacts I still maintain, and they want to be guest speakers, and I want my students to hear what they're doing. So that you're making an excellent point that I really enjoy pulling in, whether even if they can only give me 20 minutes, I'll take it and I'll weave it into a class because it is very helpful. And especially if they're young or they can even talk about their internship if they're, because sometimes the students can really relate if it's somebody closer in their age. And so even if it's a young bachelor student who worked all summer, man, come on in and I want you to talk about that so that they can perhaps share their perspective. I think that's a great point.
This is for everyone.
Yeah.
For the ones with experience and also the younger ones that they know why this is important.
Absolutely.
And you need the storytelling.
Yes, I agree.
Yeah, I think Gerhard was also making another point that if we think about all the emails that we get inviting us to webinars and so on in kind of a lifelong learning context for us, that this would be a good addition. And I've made a note of that, maybe for our next paper.
Alicia, did you
have?
Yeah,
I wanted to have everyone ask their questions first. So I'm the discussant for this paper. So most of my questions have already been asked, but that's okay. I have a few more. So I really like this paper. I really like, I liked your talk, and I also did work in consulting. And so I'm thinking about kind of two things, or I have some ideas. One is, I also think there could be a component about ethics included in this. So my understanding is that the majority of your course is from the perspective of the customer rather than from the perspective of the supplier or the integrator. And so I would argue that it is also the responsibility of the integrator to have these considerations about security of the supplied products. And so I am curious if you have thought about including ethical considerations and presenting this also as an ethical issue from the perspective of the integrator or supplier. That's my first question.
You're bringing up an excellent point. We actually did address it from all three. Our community of practice is not just the customer, but it's also the integrator, as well as all the tier suppliers. So it's actually a more of a larger ecosystem, so to speak. You've got all of these different disparate components into the whole. But you're absolutely right. This could very well have an ethics component. A good ethical case study is always fun to get their perspectives on. Let's say you've got a vendor who wants to have a back door into the code and puts it in there. I mean, what do you do when you find it? I mean, I think that there's a great opportunity to have an excellent discussion on what happens when you find this. Because of course your vendor is not going to tell you this up front, that kind of thing. And you could take that ethics case and put it in quite a few different areas. But yeah, I think that definitely is a great idea to have a good assignment regarding ethics.
And then my second question is, whenever I hear the Agile folks say Agile can be applied to everything, my resistance is always, well, I don't know about consulting processes where there's RFPs and legal documents that require that specification happen before detailed design and before implementation. And so your framework is based on waterfall, which I don't disagree with, but I'm curious at how you would pushback, or if you think this would naturally apply to Agile. I'm just curious for any thoughts that you've had about this.
I worked in a very traditional waterfall shop, but I also worked in an Agile. So we did put Agile in here. I think as far as when you're dealing with Agile development, if you're prototyping, because this is commercial off the shelf, it doesn't apply to that degree. But there are other components of an Agile shop that could, that do make a point of, that, because a lot of times, I know as a former vice president of IT, you either have an Agile shop or a traditional shop. You don't, or it's very difficult to have, unless you have a larger company where you've got mixed teams, because you've got certain clients that are going to want a traditional waterfall methodology. But you've got some clients that definitely want all of this integrated quickly. But you're right, there's going to be some cases where you've got I think you can have an Agile shop implement this, but they do need to be cognizant to make sure that you've got the right vendor, you've got the right product. You've got to have some of these other pieces in place, and no legal, every organization has a legal component to it that they're going to, that whether the shop is Agile or not, you still have the legal responsibilities to make sure that the statements of work, the acquisition process is done handled properly and holistically, and that you've got a service level agreements that everybody can live with. So I don't think it throws those out, but so it does, it's just handled a little bit differently, but it can certainly be done in an Agile shop or waterfall.
Okay, awesome. I will now be pro Agile. And my final question is, this is more just a clarification. Can you talk a bit about what it means to manage disposal activities of software?
Oh, yes. Okay, so there's always a case where companies have, I call it a software graveyard. And there are software that gets, and hardware, they come to end of life. And so you need to make sure that they are properly disposed of. Obviously, like a hard drive, you wouldn't throw out a hard drive with all sorts of data on it. It has to be properly, hopefully, although it still happens. But whether it's physically getting your drill and drilling a hole right into the hard drive or demagnetizing it, there's ways to get that data off. But of course, there are proper procedures to handle end-of-life software and disposing it properly.
So does this include like decommissioning, or,
yeah, you could call
or do you mean like after the point of decommissioning?
This would be at some point you're going to upgrade, you're going to want to implement newer versions. So your older versions, your older systems, that would, when you're end of life, you've already decommissioned it, I guess you could call it. It's no longer in production. But you want to make sure that any data tied to that is obviously scrubbed. I mean, you want to make sure that there is a proper process to decommission software.
Okay, thank you.
Okay, anyone else? Thank you for your discussion. Okay, well, I think that brings us to the end of the session. We right about on time, and thank you very much. And I guess the next thing is an hour break, right? And then the next Bastian, and then the next of the paper.
That's right.
Pierre Bork. Yeah.
That's right. Thank you. Thank you very much, Don, for chairing this session. Thank you all for the presenters and the discussants. Very, very strong program component here today. I'm really happy with this. So yes, you've got about an hour or so, 50 minutes until the next session begins, for you to do what you have to do and get some food, perhaps. And then please don't forget to join us again for the closing session, where we will be giving some awards, and we will be also hearing a wonderful keynote that I've been looking forward to for almost 2 years now. So without further ado, see you in an hour.
Right. Thank you.